Alright, so here's the video where I actually do a little bit of this stuff in IXL for you. We're doing r plus s cubed. We're finding a missing term. Shouldn't be too hard. So since it's cubed, I'm looking at the fourth row, right? That's what I'm looking at. So we have a 1. These are easy. 1, it's r plus s. If I was actually doing binomial theorem, I would say r to the copyright. I had to use r. Makes it look like copyright. R cubed, s to the 0. Plus a 3, then it's going to be r to the second, s to the first, plus 3. When I hit this row, it's a 3, r, s to the second. That was pretty obvious. Like, that was just pull numbers off the triangle and put it in there, so it should be a 3. Brilliant, I'm at a 10. Alright, just jump up until they get a little more difficult. Please, I hope they get difficult. Easy, still easy. Still easy. Still easy. Still easy. Like, seriously. Why is it this easy? Still easy. I'm pretty upset at this. You're not doing this. Nope. These are too easy. Go back. Now, why I'm mad is because that was not hard enough. That's what you need to be doing. Right there. So, you're going to do it with Pascal's triangle. This is the lesson I want. So let me assign this one. Sorry I'm wasting your time here. Okay, this is the lesson you're doing. Binomial theorem 2. This is where I need you. Use binomial theorem to complete the expansion of y plus 2 to the fifth. Well, the first term is 5. Brilliant, aren't I? Use the binomial theorem to complete this one. That one's beneath you. I honestly don't know why anybody would use binomial theorem to do this one. It's 6. You guys know to write something twice and FOIL it. Excellente. This might be interesting. Let's write this expansion out. That's all we're going to do is we're just going to write down the expansion. And they've done most of the work for us, so it's not going to be too terribly hard. I could do this in my head, and I got a feeling most of y'all could, but you're going to use the triangle to do it. A lot of people teach binomial theorem, which has got its pros and cons. It uses C and J and factorials in there. But Pascal's triangle is easy. All I got to do is draw the triangle. That's it. So the first thing you do is you take your 3y, and I'm just writing this out so I have the placeholders. I know it's already there. I know it's there. I take all of 3y, I raise it to the fourth. I multiply that by z to the 0. And I forgot to mention the constant here. Because this is a fourth degree polynomial, I'm going to use row 5. All right? This is my row right here. I wish I could highlight this, but this is my row. Plus 4. 3y is now cubed. And z is raised to the first power. Moving on, the next thing I see is a 6. All of 3y is now squared. And z is now to the second. I think that's actually where I get to stop this problem. I think it was the third piece they wanted. Oh, it was a second piece. Well, I did too much work. Who would have thought? So this is the piece I want. What's the power of z? It's the first power. Oh, they wanted more, didn't they? They want the power here. So this is z to the 0, z to the first, z to the second, z cubed. I actually wasted more of your time. Correct. All right, this is just exponent lessons, teaching you what happens to the exponents. Notice that the exponents are going up. Squared, cubed, fourth, fifth, sixth. Easy stuff. More exponent stuff. WB to the first, x to the fourth. Good work. Finally, missing pieces. That's what we want. Missing pieces. Now this wants us to find the third and fifth piece of that expansion. All right, it is a fifth degree. Because it's a fifth degree, we're going to focus on the sixth row. That's where my coefficients are coming from. So I will be looking at this row right here. 1, it's y to the fifth. The negative 2z gets raised to the 0th power. Plus a 5. Y is now to the fourth. The negative 2z is to the first. All of it's to the first, not just part of it. Next number I see on the sixth row is a 10. Y is now cubed. I don't know why I'm bothering putting that in parentheses. It doesn't need it. Negative 2z is now squared. All right, now I've got a 5. You should be catching on. Y is going to decrease. She is now a second degree. And negative 2z is increasing to the third power. Oh, I screwed up. I missed a 10, didn't I? Good catch if you caught it. Moving on to my 5. Y is now just y. Negative 2z is now to the fourth. And finally, I'm at the last piece, a 1. Y is to the nothing. It's a big deal. Anything to the nothing is 0. And negative 2z is all raised to the fifth power. So let's figure out what they want. That's first, second, third. They want the fourth term. First, second, third, fourth term. This piece has to be worked out. All right. So if you take a negative 2 and you cube it, you get negative 8. Times the 10 out front is negative 80. Y squared. Z cubed. That's that piece. They want the last piece, which is this one. That's pretty simple. That's negative 32z. If you take a negative 2 and you raise it to the fifth power, I swear it's negative 32. Probably shouldn't swear, but it is. That is going to be negative 32z. To the fifth, sorry. Forgot my exponent. Those are what you can plug in place. All right, let's jump up and see if there's anything harder. It says there's 6 levels on this one. That's the full expansion. I did one of those. It was the first video I did. Did something harder than that. Fifth degree, I did something harder than that. And that looks like it tops out there. So I think I'll have you guys do this to an 85. So 85. And I'm sure you'd love to see more examples here, but you don't need it. It's easy stuff.